Good morning, students. So, welcome to the first session of 10th class electric current chapter number 9. So, here in the first class, we are going to learn some objectives. So, introduction to the electricity. What is electric current? What happens to the motion of electrons when a battery is connected to it? So, like this, we will be going to this one. First one, let us see what is electricity. So, before going to that, we have to go through the modern physics. Let us see atomic structure topic is there in chemistry. Inside an atom, so we have three subatomic particles, namely protons, electrons and neutrons. Where protons and electrons are inside the atom, that is the protons and neutrons are inside the nucleus and they are called nucleons. So they will not come out of the nucleus. Around this nucleus, electrons are revolving around this nucleus freely, they are randomly distributed. That means electrons are in motion, whereas compared to positive charges like protons are not in motion. So in that case, why they are not? In that case, there are two types of electricity. We say so. Electricity is divided into electricity is of two types. Divided into two types. One is up to the 9th class. We have studied here static electricity, and current electricity. So here in this one, the static name indicates here stationary. Static, the name itself we are having stationary. That means the study of charges at rest. That is called static electricity. In this one, the charges are not moving from one point to another. They are at rest. In this study, the charges are at one rest, that is one place, like cell, battery, charges are at rest. So that kind of study is called static electricity. And if the charges are moving from one point to another point, so that is called current. Current means the word current stands for motion, that is flow. So that means current is there is motion, that is flowing from one point to another point. Here static means rest. Here current meaning, only this current meaning is nothing but they are motion. That means the study of various effects of charges in motion, that is called current electricity. The study of charges at rest is called static electricity. So static electricity we have dealt with primary cell, so Lagrange cell and many type of cells that we study at rest. We have studied up to the previous classes. Now we are going to learn about the electric current and what are the effects when they are traveling from one place to another point. That means one point to another point. So in this one, when these charges, that means electrons, they will not go from. The charge of electron is denoted by the letter Q. This charge of electron is moving from one place to another place. So Q is moved, that means charge of electron, that means electron charge I will be writing. So the charge of one electron is given, as 1.625 into 10 power 18 electrons. That means these many electrons, whatever the amount of charges offered by these many electrons, that total constitutes 1 coulomb of charge. That is 1 coulomb of charge here, charge of 1 electron. So if there are 2 electrons, that means 2 into E, that is the charge of 2 electrons, 1 electron, 3 electrons are there. Like that, if n electrons are there, we will write n into E. That means charge is equal to, Q is equal to, charge is equal to n number of electrons into charge of 1 electron will be giving you. So that means charge of 1 electron will be giving that kind of value. Now here in this situations, how the electricity will be flowing? That will be flowing. In which situation it flow? Let us see a small battery. A battery is a battery. So 9 volt battery we have taken, and I am taking a series, right? Actually we have to take a bulb, but we can perform in the alternative manner also. See, this small terminal is considered as positive and this is to be negative. Then I am taking this one and I am connecting positive and negative. So positive and negative. So here now the lights are glowing. Lights are glowing. That means whatever the chemical energy is stored in this battery is converted into electrical energy and passing through this the wires and entering into this LED bulbs, light emitting diode, that is LED bulbs, and these are glowing. So like this. Now, if I remove this battery, they will be not glowing. The wires are there. Already these wires are there through which current will be flowing. These wires are called conductors, even though they are connected. So when I place this one, now they are glowing. When I place, they are glowing. That means flow is being happening here. Chemical energy is converted into electrical energy. That electrical energy is traveling from positive terminal to negative terminal. So they are glowing. So if I remove this one, they are not glowing. That means in the absence of battery, there is no source. This is called a source energy, which is giving you. This one is called, that means energy is called source. And this is taking energy, and that means electrical energy, chemical energy is converted into electrical energy. That electrical energy entering into these bulbs and converted into light energy and heat energy also. So this is called consumer. So when I connect, they are glowing. When I remove this one, they are not glowing. Instead of that one, if I take insulated wire, insulated means wire bound with some kind of threads like this. This kind of wire if I take and connect to this one is connected to the positive and other is connected. So here cell is there, another one is I am connecting with the help of this one. I am connecting. Now the LEDs are not glowing. That indicates, that means this, whatever the first wire is there, that is a conductor. This wire is having some thread around the wire. See, some thread is there, insulated wire. Thread is there. This is nothing but it does not allow the electric current to pass through it. That means they are not allowing the electric current to pass through it. So the substances which allow electric current to pass through them are called conductors. So this is a conductor, this wire is a conductor. That's why through the conductor the current is flowing. And in the first case, the current is flowing, therefore the bulb is glowing. In the second case, as there is no source, so the bulb will not glow. And the series lights will not be glowing. In the third case, when I take the insulated wire, so insulated wire does not allow, even source is there, and suppose this is the bulb, this is the bulb here, where bulb is there, this is the bulb, and here, this is the battery. Like this, when the battery is connected and these wires are there, then the bulb is glowing. This bulb is glowing. If I remove this battery, even though these are conductors made up of copper conductors, so then the bulb will not glow. Why? Because there is no source here. That's why this will not glow. When battery is also connected and this battery is also connected and this wire, instead of this wire, only we are having insulated wire or nylon wire. Or insulated wire or nylon wire is there. Through this one, this will be giving energy, but that is not ready to accept or take the energy and pass through the bulb. Therefore, the bulb will not be glowing. From this situation, I can come to a conclusion that conductors and non-conductors. Non-conductors, and this means other name of, that is opposite name, that is conductor means the material which allow electrical energy to pass from the source to the bulb. Here in this case, source is the battery, from the battery to the bulb are called conductors. So the material, that is I told nylon wire, the material which does not allow the electrical energy to pass from the battery to the electric bulb are called non-conductors. The other name for non-conductors is insulators. Insulators. These are conductors and these are insulators. Insulators does not allow electric current to pass through them, but conductors allow electric current to pass through them. This is how we say. Now we are getting one energy. I am saying energy is being transferred from the source to the bulb. Which energy? That hidden whatever the energy is inside the battery, that chemical is energy. That chemical energy is being when the two conductors are connected, that chemical energy is converted into electrical energy. That electrical energy is being flowing from one point to another point. That means from positive terminal to negative terminal. Let us see what happens, how it is flowing in this one. So I am taking the structure, that is nothing but this is a conductor, and then the area of this cross section, area of cross section is same. This is having a area A. A is the area of cross section of that particular conductor, and we can say thickness. Simply we say thickness of the conductor. Now in this one, electrons are, that means negative charges are there, positive charges are there, negative charges are there. So I will denote by negatively charges. This charge is moving in this direction. This charge is moving in this direction. This charge is moving in this direction. So this charge is moving in like this. They are randomly moving. They don't have any specific path for its motion. So one will be moving like this, randomly distributed. What happens here? The number of charge carriers passing from one point, from this section left to my left to my right. That means the number of charges traveling from my left to right in a particular time is equal to the number of charges traveling from right to left in the same time from right to left. That means whatever charges are going in this one, magnitude of the charges, suppose m, and this side is minus m. So if you add these two plus m and minus m, automatically the answer will be 0. Therefore, the net charges, that is the net charge in this conductor is 0. Net charges in this conductor will be 0. So for that case, that means they should travel in only one direction. They are traveling from random direction, no? So they should travel only in one direction. So how they will be traveling? So when I take this one from left, this is one, this side, this side 2, that means two ends of the conductor. Then if I connect to a battery or cell, or from this one, they will be traveling from one place to another place. That means from one point to another point in only one direction, in only one systematic order. So let the order, the order will be only from point, that means from the negative. This is negative, this line, and this will be positive. This negative will be giving the electrons, and these electrons are traveling and like this, they are traveling like this. And the current will be going in this opposite direction, that means positive charges. So they will be coming and traveling in this direction. So they will be electrons, and whatever here positive are there, so they will take the electrons. Then positive will attract the negative charges. You know this one. Positive negative will attract, means like charges repel each other, unlike charges attract each other. In the same way, this will be coming, or we can write this direction and this direction, and all will be coming aligned in this order. Therefore, there will be no cross, that is nothing but opposite direction flow of charges. Therefore, charge will be coming from one direction and that is going to another direction. So here positive, we can say positive charges and negative charges are coming, that is coming positive from higher potential, that is positive terminal to negative terminal. Or electrons, charges are coming, charge is flowing from to lower potential, that is negative terminal, to the higher potential, that is called positive terminal. So this is how what is happening in the ideal conductors like copper wire or aluminum wire. So like that, if you take that kind of us, what is happening? Ideal wire, if there is no source, nothing is there. So the net charges is, net charge on that particular conductor is 0. So that's why that is not behaving, that is not giving any supply. So when you connect this one, there will be a continuous flow of charges. That's why they are flowing from one to another. During its flow, as we have discussed in a charge, there are some positive charges are also there. See here, positive will not move. So they will be at rest means. These positive charges are having some fixed arrangement. They will be having some arrangement. These positive charges will be having some fixed type of arrangement. This arrangement of positive charges in a conductor is called lattice. L-A-T-T-I-C-E. That is the lattice, a group of L-A-T-T-I-C-E. Lattice, a group of positive charges arranged in a conductor. So they will not move. They will act like a hot substance. They are like a forbidden. That is nothing but the substance which stops the flow of charges. So when these are going, so they will be coming here. They will be forming a hot substance like this, and here this will be coming. These charges will be coming with high velocity, and they will hit here. That means they will hit the lattice. Charges, that means whatever the negative charges are there, they will come with high speed and they will hit this lattice. They will accelerate, will be accelerated, and when they hit here, what happens? Certain. That means when they hit here, there is a chance of becoming, their velocity will be almost 0 or equal to 0. But due to electric field, what happens? Again that electron will be, a charge will be accelerated with the help of electric field, and that will be traveling fastly, and that will hit the another lattice, and that will be going. Due to that one, what is happening? This conductor is getting heated up. So because of that one, this is getting heated. So when you going fast on a vehicle and apply sudden brake, what happens? The tires will be rubbed on the surface of the road, and then the heat is produced. Or when you apply the brake, if you see the rim and the brakes, what happens? There will be heat is produced, something. So because of friction, here also, when they are going, something is opposing them. That means something is stopping them. Due to frictional force, some heat is produced. Therefore, this conductor will be heated up. So whenever current is passing, that will be heated. So some concepts have been given. So what happens when you connect a battery to a conductor? When you connect a battery to the conductor, the motion of electrons will be traveling from one point to another point systematically in a particular direction. They will not have deviate. They will not travel in opposite direction. When you don't connect any kind of battery or source, then what happens? They will be overlapping, and what happens? The net resultant force, that is nothing but resultant force will be 0. Or we say the resultant charge will be 0. So this side plus I, that side minus I gets cancelled, get net charge will be 0. Therefore that is a not conductor. So we cannot say it is a conductor or insulator. The net charge will not be flowing from that one. So this concept was later in 1905, that is nothing but in 19th century, in 1905, two scientists, first scientist is nothing but Paul Drude, D-R-U-D, Drude, and Hendrik Anton Lawrence. These two scientists has given the concepts of this particular behavior of conductors, how the current will be flowing, and how it is getting abstracted with this one with the help of a diagrammatic system. That will be discussed in the next class. So with this, we will conclude this one. Thank you.